This is the office hours video for section 10, scalar and vector quantities. Now, in physics, there's a big difference between a scalar and a vector. And most of you already know what a scalar is. A scalar is just some number with a set of units. So, for example, how many apples? You might say 10. 10 apples. That's a scalar. But a vector is not just a number, it also includes a direction. And so vectors are probably the thing that you're trying to grapple with at this point. One thing you need to learn right away is how to add vectors together. This is going to be a very important skill. Most things in the universe are vectors. They have directions. So you can move in a particular direction. A force can act in a particular direction. And the direction is just as important, if not more important, than the number itself. So what I'd like to do is think about adding and subtracting vectors graphically. So imagine that we had two vectors. So here's one vector. I'm just going to give them pretty generic symbols. I'll just say that's the vector A, and this is the vector B. And whenever you go to add two vectors together, you'll eventually be using the component method to get an accurate answer. But it's also important to draw the vectors graphically so you can see what's going on, and also it's a good way to check your answer, get a feel for what's happening. So if we added these two vectors together, what would that look like? What would A plus B be? Now there's several different ways to add vectors graphically. One way is to just draw the first vector. So I'll do that here. There's the vector A. And then draw the second vector starting from where the first vector ended. So there's the vector B. And then the sum of the two vectors will be the line connecting where you started originally, the beginning of the first vector, to the arrowhead of the second vector. So it'll look like that. So A plus B would be that line that I just drew. Another way of doing it is called the parallelogram method. So what you do in that case is draw the vectors twice, make a parallelogram out of them. So the two vectors, the vector A that I drew twice is, those two lines are parallel, and the vector B that I drew twice, those two lines are parallel, so this is a parallelogram. And then you connect the corner where the two vectors started to where the two vectors ended. So you can see in either case you get the same vector. So A plus B, I'm going to draw sort of a curvy line now. A plus B is that vector there in the middle of the parallelogram. Now how would you subtract these two vectors? What would that look like? What would A minus B look like? The trick is to rewrite this as A plus negative B. So essentially what we're going to do is still add the two vectors, but the two vectors that we're adding are not A and B, but A and negative B. So what's negative B? Well, negative B is the same as B, it's just in the opposite direction, 180 degrees opposite. So I'll start off again by drawing the vector A. This is called the tail to tip method. Now I'm going to draw the vector B, but in the opposite direction. So it used to point to the left, and now it points to the right. And so if we use the tail to tip method, here's the vector B starting where A ended. If we use the parallelogram method, here's the other vector A on the other side. Here's the vector B up here. So either way, when we add the two vectors together, we get a line that looks like that. So if you subtract A and B, the result is something that points up and to the right, and if you add them, it's something that points up and to the left. So you can see you got something different whether you subtracted them or added them, and that makes a lot of sense. Another thing you might run into is what happens if you add more than two vectors together. So I'll start off with A and B again, just to keep things consistent. Here's A, here's B. And now let's add in another vector, C. So I'll take C to be this vector, make it long and pointing down. Now in this case you can't use the parallelogram method because there's more than two vectors. So you have to use the tail to tip method. So I'll start with the vector A. So I'm adding all three vectors together. Then where A ended, I'll draw a B. There's B. And then where B ended, I'll start the vector C. So there's the vector C. So now, what would be the sum of these three vectors? It's the same rule as before. You start at the beginning of the very first vector that you drew, which was A, and you draw an arrow going to where the last vector that you added ended. So this thing right here that points down and to the left, that is A plus B plus C. All three vectors added together. So this is not the end of the story. This is just part of what you need to do to be able to add or subtract vectors, is to draw a diagram so you can see what's going on. It's good to do this conceptually. It's also good to do it to check your answer once you're done adding the vectors using components. And in practice, you will add them using components to get a more accurate answer. Drawing them like this is good conceptually, but not as accurate as using trigonometry and algebra. So, in summary, make sure that you add the vectors graphically or subtract them graphically whenever you have a problem. Don't skip over that step, because it'll be very easy to get lost otherwise. That's good advice. Thanks a lot.